I'm Anil Kumar. Welcome to my series on trigonometry of compound angles. Now in part 2, we will learn how to solve trigonometric equations involving compound angles. Here are 3 examples which are very popular, and if you do these examples, you should be in a position to solve most of the trigonometric equations involving compound angles. The first one is sine 2x minus 2 cos square x equals to 0, and we need to write answer in a specified domain 0 to 2 pi. The other two, we have to provide general solutions. So whenever the condition is not given, you have to provide general solution, right? Now, we'll solve them separately, but let's look into some formulas involved. When we have sine 2x, then remember the formula sine 2 theta is equals to 2 sine theta cos theta. Once you apply this formula, you can factor and solve the equation very easily. So that is the hint for A. For B, you see something times cos x plus something times sin x equals to square root 2. You could always write this equation as, let's say, cos A times cos x plus, we can write sin A times sin x. We can use this formula, and then we can use cos of A minus x. And if I could write it in this form, the left side, and we could actually solve it, right? So that's the whole idea. So in doing so, we normally take the numbers involved, and we actually write r times this, so that we could take care of any coefficient of these numbers. Let's begin with the very first one, which is sine 2x minus 2 cos square x equals to 0. So we could rewrite this. Let me copy the question first. Sine 2x minus 2 cos square x equals to 0. Sine 2x can be written as 2 sin x cos x using the double angle formula, right? Minus 2 cos square x equals to 0. Now we can factor 2 cos x. And what we get here is sin x minus cos x equals to 0. So that gives you 2 different factors. So one, we could have cos x, or you can say 2 cos x equals to 0. And within this interval, when is cos x 0? So there are only 2 values for which it is 0. So you can always see it from the graph of cosine function. It's a good idea to really draw the graph. And we know these are the 2 values for which x will be equal to 0. So from here, we get x equals to pi by 2 and 3 pi by 2. Correct? Now let's find the zeros from the second factor, which is sin x minus cos x equals to 0. So you can take it on the other side. So you get sin x equals to cosine x, and then divide. So we get sin x over cos x equals to 1, and that is tan x, correct? So tan x equals to 1. So you know tan x is 1 for pi by 4. And so that gives you x equals to pi by 4. So we have 3 solutions for this particular equation in the given domain, and the solutions are pi by 4, pi by 2, and 3 pi by 2. So that is how, because it was 0 to 2 pi, we also have in the third quadrant tan is positive. So 5 pi by, so let me just wait. So for cos to tan to be 1, we have 2 solutions. One here, pi by 4, which we wrote. The second we were just about to miss. So this is 5 pi by 4, right? So and 5 pi by 4, correct. So we, as expected, should have 4 solutions for this equation, and these are the 4 solutions. Now here is the second question. We need to solve square root of 3 cos x plus sin x equals to square root 2. Now the trick involved to solve is we are looking for some value of r, which is square root of this square plus that square, which is the coefficient of sine. So square root of square root 3 square plus 1 square. That is square root of 3 plus 1, which is 2. So if I divide both sides by 2, so what we are going to do here is we are going to divide both sides by 2. So in that case, we get square root 3 over 2 cos x plus 1 over 2 sin x equals to square root 2 over 2, right? Now, the form which you get here is square root 3 over 2. If you look into special triangles, square root 3 over 2, you could relate it to this triangle, which is pi by 3, 90 degrees, pi by 6, correct? Now in this triangle, if I have to write square root 3 over 2 as a cosine function, then square root 3 over 2 could be written as cos of pi by 6, correct? So I'm replacing this with cos of pi by 6 times cos x plus. Now here, sine of pi by 6 is 1 over 2. Do you see that part? So we get sine of pi by 6 times sine x equals to 1 over square root 2, right? Or you could even write square root 2 over 2. Let's keep it as such. Now this reminds you of the cosine formula, which could be written as cos of x minus pi by 6. Well, in cosine function, we know that cos of minus x is also equals to cos x, right? So, strictly speaking, I should have written this as cos of pi by 6 minus x when I kind of write like this. But this is same as cos of x minus pi by 6. Okay? So, or I could have written pi by 6 as a second number. But either way, for cosine, interchanging this position doesn't really make much difference. On the right side, we have square root 2 over 2, which is cos of pi by 4. Correct? So that value of 2 over 2 is actually for cos of pi by 4. So from here, we can say that x minus pi by 6 is equal to pi by 4, right? Now, for cosine, let's look into this once again. Pi by 4 cos is positive in, actually speaking, both these quadrants, correct? So it is both plus and minus. So what you could do here is you can write general solution as plus 2n pi, where n belongs to integers. So that gives you a general solution, correct? So from here we can write x is equal to, taking this to the right side, rearranging our terms, 2n pi plus pi by 4 plus pi by 6 gives you 2n pi plus 12 is the common denominator, right? And what we get here is 3 plus 2, so let me write 3 pi plus 2 pi, which gives you 2n pi plus 5 pi by 12 as the solution. So that is how you could actually solve this equation. So here is the last question. We need to solve cotangent x plus cosecant x equals to square root of 3. So let's begin by writing it in terms of cos and sine. So cot is cos x divided by sine x, and cosecant is 1 over sine x. We get this equal to square root 3. We can take sine x as common. We get cos x plus 1 equals to square root of 3. Cross multiply, so we have cos x plus 1 equals to square root of 3 times sin x. Bring cos and sin together, we have cos x minus square root of 3 sin x equals to minus 1. And now this is similar to the previous question, right? So we are going to use our method of dividing both sides by some number, and that number is square root of 1 square plus square root 3 square, correct? Which is square root of 1 plus 3, which is square root of 4, and is equals to 2. So we could write this as half of cos x minus square root 3 divided by 2 of sin x equals to minus half. Do you understand this step? Now this is a very critical step to write it in cos a plus b form, right? So half. So we are now reminded of our special triangle, which is pi by 3, pi by 6, pi by 2 triangle. So in this triangle, this angle is pi by 3, the sides are 1, 2 and square root of 3. As you can see, half could be written as cos of pi by 3. So I'll write this as cos of pi by 3 cos x minus square root 3 over 2 is sine of pi by 3 sin x equals to minus half. You could actually write this as cos a plus b, right? So this is written as cos of a plus b, let me write x first, over pi by 3 is equal to minus half. So we get the form which can easily be solved, and we can now find what x is. Now let us see when is cosine minus half. Now this is also confusing for some students when they want to write general solution. Now when we say cos is negative, we are looking for two solutions. One is in quadrant 2, the other one in quadrant 3. So the angle here is 2 pi by 3, and the angle, this angle, is minus 2 pi by 3. Do you see that part? So in general, we could write this as 2n pi plus 2 pi by 3, where n belongs to set of integers. So when n is negative, you are going from this side. You get the idea? So you cover all the angles. So this is kind of very critical to understand, especially when we are trying to write a general solution, right? So this is very important to write general solution. Okay. So we could write x plus pi by 3 equals to 2n pi plus 2 pi by 3. Solve for x, which is 2n pi plus 2 pi by 3 minus pi by 3, or 2n pi plus pi by 3. And we know n belongs to integers. So that becomes our solution. Is it okay? So our answer here is x equals to 2n pi plus pi by 3, where n belongs to integers. So I hope with this you learn the techniques of solving trigonometric equations involving compound angles. Now this kind of equation at times could be written as, we also call this as wave equation, right? So I'll refer to you, we have some equations which we call wave equations. And this form comes from there also. So we are trying to write our equation as r of cos, let's say alpha times cos of beta, plus or minus r of sine alpha times sine beta, equals to some number k, right? So these kinds of equations, if written, can be written in the compound angle formula and solved just as we did here. So I'll provide you with a link where you will understand how to use a wave equation to solve the same question. Perfect? I hope that makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, that will be great. Thanks for watching and all the best.